Got a submission here from Stoichiometric, who is having problems with coupling of pitch and throttle. This is a very common problem, and I want to just talk about it in general a little bit before we look at your data. The problem happens when you raise the throttle abruptly and the copter pitches forward, or when you drop the throttle and the copter pitches backward, or maybe it happens the opposite direction. I can't remember. It may not be the same for everybody. It's commonly thought that the reason for this is that your CG is offset. I don't think that's what the cause is, at least not mostly. And the reason I say that is that my copter used to have this problem, and I tried moving my CG all over the place, and I looked at the effect in Blackbox. And what you see is that on my copter, when I was in forward flight, the I term was positive. That means the I term is applying a pitch forward moment, or force, which means that the copter has a persistent bias to pitch backwards, which you would think would mean that the CG was aft of center. But the CG was not, it was like a half a centimeter aft of center. And I moved it forward, so it was forward of center, and the I term changed a little bit, but not very much. So my conclusion was that there is a primarily aerodynamic effect that is causing this pitch back moment when in forward flight, and that is the primary thing that the I term is fighting, that the CG is having a relatively small effect here. You can test this for yourself. Your I term is very positive during forward flight, and you can try moving your battery all over the place if you want, or use a smaller battery. And I think what you'll find is that your I term will get a little smaller, but it won't be close to zero, and that's because the aerodynamic effect is dominating. What is the aerodynamic effect? I will start by saying that I don't know. There are people who make their living discussing the things that propellers do to air, and I am not even remotely one of them. But we do know that when a copter is in forward flight, the back props are interacting with the prop wash from the front props. So, I don't know. I don't know. It's plausible that there is a throttle-dependent effect that is resulting in a pitch back or pitch, usually I think it's pitch back, a pitch back moment, which is causing the rear motors to make less thrust effectively. Maybe we could argue that the turbulent air coming off, the high pressure air coming off of the front props is interacting some way to reduce the effective lift or thrust of the rear motors. I'm just making that up. I mean, I don't know. Or maybe the front motors are creating a low pressure cell that the back motors have to draw from, so the back motors are less able to draw. Yeah, that actually sounds plausible, right? If you think about it, the front motors are sucking in air, and they're interacting with the cleanish air that is hitting the front of the copter. In fact, it's higher pressure air because the copter is flying forward, right? And it has a frontal surface area. And then the rear motors are interacting with a slightly lower pressure air because the front motors are sucking in air and creating a low pressure zone in front. And so the rear motors are less able to suck in air, and they have to spin faster to make the same amount of thrust. I just made that up. It sure sounds good, doesn't it? Is it true? I don't know. But what we do know is that the I term is positive in forward flight, meaning a pitch forward moment counteracting a persistent pitch back force, and that moving the CG of the copter, at least in my experience, has a minimal effect. So, it's probably aerodynamic is my conclusion. So, the I term has to be able to respond fast enough to, back up. The PID loop has to be able to respond fast enough to throttle changes, because the degree to which this effect is active changes depending on how fast you are flying, how far forward you are pitched. In other words, if you were to punch out in a flat hover, you wouldn't get any of this throttle-dependent effect. The copter would just pitch straight up. Well, actually, the CG would affect you just as much when you're in a flat hover, but the aerodynamic effect would be balanced between all four motors. So if you try this, line of sight, hover flat, and then do a full throttle punch, and you will probably see relatively minimal coupling of pitch to the throttle. But when you're in forward flight, this aerodynamic effect is going on, and your throttle-dependent pitch coupling aerodynamic effect occurs. So the PID loop has to be able to move fast enough to address this, and it's not. And that's why when you punch the throttle, the copter pitches forward or back. So what do you need to do to make this better? Well, first of all, I've seen copters, not personally, but I've been told about them on forums, where nothing the pilot did could fix this. And of course, you know, you could say, well, maybe if they were a better tuner, they could fix it. I don't know. Maybe they were a good tuner and it was just unsolvable. I personally couldn't fix this on my 3S setup until I got a decent set of ESCs. And I don't know why. I don't know. But as soon as I got a decent set of ESCs, I went from some F12A ESCs to some little Bs. It got way better. And when I went from 60-30 props to 60-45 props, it got way better. Okay, so if you do everything you can do to tune this out and you still haven't fixed it, the next thing to do is to start looking at your equipment. Now, your equipment, unlike my equipment when I was having this problem, which was terrible, not great equipment, your equipment is like clearly all of this equipment is capable of flying perfectly. Okay. Except I don't know your frame. Let's look at your frame and see if there's anything funky about it. There probably isn't, right? What? It's not like images. Yeah, so it's a pretty normal frame. There's nothing funky about this. Little bit of a sort of a weird motor layout. I don't think that should be affecting you too much. I can't tell from the photos whether the motors are square or whether the rear motors are closer in. I think it's just an effect of the photo. Maybe the rear motors are a little further in, and that's having some effect. I would expect that to create roll to yaw coupling. In other words, when you roll, you also get yaw. But I wouldn't expect that to affect pitch at all. Okay, anyway. So what do you do to your PID loop to fix this issue? Okay. You get, number one, as always, you want the P term doing as much work as it can. The I term is slow. Okay, it's slow and steady. If you rely on the I term, you will have a very unresponsive copter. We need to make the P gain be as high as it can be on pitch without introducing bad effects. And then we bring up the I term to a level where we feel like the problem is handled. And so you've got an I gain of 330, and my experience with my copters is that I gain on pitch usually ends up in the realm of 50 to 60 in order to control effects just like this. Not so much throttle, not so much when I punch the throttle, but when I climb out and chop the throttle, or if I'm in a turn, a sharp turn, and I chop the throttle, the copter needs to maintain stability, and that's why I end up raising I on pitch. So potentially you'll need to raise I on pitch, but don't do that until we check and see if your P is raised high enough. Because again, we want P doing as much work as possible and I doing only the leftover work that P couldn't get. Okay? Now, let's go ahead and take a look at your logs. Here is an example I found of a situation where this is happening. You're going to cut the throttle. You've punched and you're going to cut the throttle. Let's go ahead and watch that. Oof, a pretty big dip. Let's go ahead and back up and see what's going on with your gyro and your PID loop. So here, as you raise the throttle, we can see that the I term goes more positive. And in fact, what I'd really like to see, this is a new one on me, I'd like to see your RC command of your throttle and your I gain, your I term on pitch, and watch them together. So we can see, interesting, very interesting. We can see some interaction between them, but for example here, notice that you cut the throttle and the I term responds slowly. And boy, there's a big drop there. So I term is positive, that's pitch forward. As you cut the throttle, let's just step through what happens. As you cut the throttle, gyro goes positive, meaning that you're pitching forward. Your stick is centered, so this pitch forward motion is uncommanded and error rises. P term goes negative. P term goes negative, gyro continues to rise, and only after the I term finally joins in the party does the gyro begin to fall. But the gyro falls really quite slowly. The gyro is now close to the 0 axis, meaning that the copter is no longer pitching forward. It's still pitching forward a little. P term begins to rise as error is reduced. I term stays negative, pushing back. So I term is negative now, is continuing to pitch back. Gyro begins to go negative. So what's happened here is that the problem has been, well, for the moment the problem has been fixed, but the I term is still trying to unwind previous error and get the copter back where it needed to be, so the copter begins to pitch back. P term is now opposing it. What a mess. It's a real mess. So what you've got here is this throttle to pitch coupling is just a thing that some copters do, and it's being exacerbated by the fact that your PID gains are kind of out of whack, and they're not right. There's so many times where P and I are opposing each other. A well-tuned copter, let me get this out of here. A well-tuned copter will have relatively minimal time where P and I are opposing each other. And notice that what happens is P goes positive and I is negative. Oh, I comes around as I is like, okay, fine, I'm positive. We're both positive. And P goes, nah, I changed my mind. And I goes, what? No, I just got here. Okay, here I come. I'm going negative now. Okay. Okay, that does not make for a good flight experience. Okay, so what should you do? The first thing to do is to make sure your P gain is as high as it needs to be. And I'm going to look through here and look for signs of bad P term behavior. And I don't see any. I don't really see. Well, that's a flip. We'll forget about that. I don't see any sort of signs that you're beginning to get into an oscillation scenario. I don't even see any of the surging that I've pointed out in previous videos. Not really any surging even. Barely starting to see some peaks here. So I think your P gain needs to come up to start with. I think your P gain can come up 1.0. I'm a little surprised to hear myself saying that because... Oh, whoops, sorry. No, you're on Lux Float. Hang on, don't do that. Pitch of 1.3. Take your pitch P gain up to 1.7. 1.7. That's what I think. Now, you sent me a bunch of other information. P have tried it at higher values, but I think it's good where it is. Well, I think it should be higher. I think it should be higher. I think this problem is... See, here's the thing. What can you do to fix this problem? Well, you can raise I gain, and I will respond more quickly, and that may help, actually, because your I gain is a little low. So if you really are resistant to raising P, then raise I to like 55. But I feel like that is not the optimal solution for a good flying copter, and that having P a little higher would be better. But if you don't want to raise P, then raise I on pitch to like 55. That's what I would say. And then don't even touch D. D looks fine. It could probably be a little higher. It looks a little underactive to me, just in terms of its overall magnitude relative, see how P is way off the mark here. but D is kind of just low. You know, it's down here. P is up here. D's down here. I'd like to see D be a little more active. But don't even touch that until you get your P and your I sort of dialed in. Okay. Well, I hope that was helpful, and happy flying.